Hello viewers, in today's class we are going to discuss an important topic in three-dimensional geometry, and the topic is the plane passing through the intersection of two given planes. Now here we will discuss the intersection of two given planes. So here we are given two planes P1 and P2, and the equations are given as a1x plus b1y plus c1z plus d1 is equal to 0, and the equation of the second plane is a2x plus b2y plus c2z plus d2 is equal to 0. Now in geometry we know that suppose we have a line L1 and suppose we have another line L2, and if these two lines intersect, then they intersect at a point, right? So L1 and L2 are, say, two lines, then they intersect at a given point. In the same way, if we have two planes P1 and P2, and see this is the line of intersection of these two planes, and the plane passing through the line of intersection of these two planes can be drawn as, because this is the line of intersection of these two planes, so we can write, or we can draw a plane like this. See, this is the third plane, right? So this is the plane, say P, which passes through the line of intersection of these two planes. So this is the line of intersection of the two planes, of the two given planes, right? So what we have concluded here, so when two lines intersect, the lines intersect at a point. This is a point. But when two planes intersect, they intersect in a line, and the line is called the line of intersection of the planes, and the plane passing through this line of intersection of these two planes is called the intersecting plane, right? Now our aim is to find out the equation of this plane, right? We want to find the equation of plane P, and we know that the equations of the planes P1 and P2. So the equation of this plane P is given by P1 plus lambda P2 equal to 0, where lambda is some unknown quantity, and the equation of the plane which passes through the line of intersection of these two planes P1 and P2 is given by P1 plus lambda P2 equal to 0, right? Now if we substitute the values of P1 and P2 here, we get a1x plus b1y plus c1z plus d1 plus lambda times we have a2x plus b2y plus c2z plus d2 is equal to 0, right? So this is the required Cartesian form of the equation of the plane passing through the intersection of the given planes for each value of lambda, right? So this is the Cartesian form of this plane P, right? Now let us consider the vector form of the intersection of these two given planes. So let the vector equation of the plane P1 is vector r dot vector n is equal to d1, and let the vector equation of this plane P2 is vector r dot n2 vector is equal to d2. Right? Now let t be the position vector. Let t be the position vector of any point which lying on the line of intersection of these two given planes. So here this is the line of intersection of these two planes, and suppose t be the position vector of any point which lie on this line. Right? Now since t is the position vector of any point lying on this line, so therefore this vector must satisfy these two equations. So therefore we can write vector t dot vector n is equal to d1, and vector t dot vector n2 is equal to d2. Right? So now the equation of the plane P, which is the intersecting plane, so the equation of this plane P can be written as vector t dot vector n1 plus lambda times vector n2 is equal to d1 plus lambda times d2. Right? So viewers, this is the required vector equation of the plane which is the intersecting plane, and this is how we can find the Cartesian equation and the vector equation of the plane passing through the intersection of two given planes. Right? So viewers, let us take some problems. Now viewers, let us take this problem. Find the equation of the plane passing through the intersection of this plane and the point 1, 1, 1. So here we are given the vector equation of the two planes, and this is the plane P1. The plane P2 is given by this equation r dot here we have 2i cap plus 3j cap plus 4k cap is equal to minus 5. Now this is the plane P1, this is the plane P2, and we have to find the plane or the equation of the plane which passes through the intersection of these two planes. And see, this is the line of intersection. This is the line of intersection. Right? So this is the line of intersection, and we have to find the equation of this plane. So this equation, the required equation of this plane P can be written as we have discussed in our the topic, that the equation of P can be written as P1 plus lambda times P2 equal to 0, and we have to find the value of lambda, and the condition is given here that this plane passes through the point 1, 1, 1, and let us say that the point lies here. Right? Suppose this is point Q, and Q has coordinates 1, 1, 1. Right? Okay, so P1 plus lambda P2 equal to 0, and we have the equation as vector r dot n1 plus lambda n2 equal to d1 plus lambda d2, right? So if we substitute the values of vector n1 and this is vector n2, and d1 and d2 are 6 and minus 5 respectively, right? Because the equation of this plane P1 is of the form vector r dot vector n1 is equal to d1, and this plane is vector r dot vector n2 is equal to d2, right? Now here vector r is xi plus yj plus zk, and this is dot. Then vector n1 is I cap plus j cap plus k cap plus lambda times vector n2 is 2i cap plus 3j cap plus 4k cap, and then d1 is 6 plus lambda times of minus 5. Now viewers, this can be written as xi cap plus yj cap plus zk cap dot, and here we have collecting the like terms, we have 1 plus 2 lambda I cap, then we have 1 plus 3 lambda j cap plus 1 plus 4 lambda k cap, right? And this is equal to 6 minus 5 lambda. Now taking the dot product of these two vectors, we get x times of 1 plus 2 lambda, then we have y times 1 plus 3 lambda, then we have z times 1 plus 4 lambda equal to 6 minus 5 lambda, right? Now this is the equation of the plane P, and since the plane P passes through this point 1 comma 1 comma 1, so here we will substitute the value of x equal to 1, y equal to 1 and z equal to 1. So if we substitute here, we get 1 plus 2 lambda plus 1 plus 3 lambda plus 1 plus 4 lambda equal to 6 minus 5 lambda, right? Now if we solve this equation, we get 1 plus 2 lambda, then we have 1 plus 3 lambda plus 1 plus 4 lambda equal to 6 minus 5 lambda. So this is 4 plus 3 7 plus 2 9 lambda, and this is plus 3, and this is 6 minus 5 lambda. So this can be written as 9 lambda plus 5 lambda equal to 6 minus 3. So we have 14 lambda equal to 3, and the value of lambda is 3 by 14, right? So we have obtained the value of the unknown lambda equal to 3 by 14. Now we can substitute this value of lambda in our this equation. We can substitute either it in this equation or in this equation, right? Here also we can substitute. Now if we substitute lambda equal to 3 by 14 here, then we get x times 1 plus 2 times 3 by 14, then we have y times 1 plus 3 into 3 by 14 plus z times 1 plus 4 times 3 by 14 is equal to here we have 6 minus 5 times 3 by 14. Now if we simplify this expression, this is 6 and 14 ones are 14, so we have x times 20 by 14. Here we have y times 23 by 14, and then we have here z times 26 by 14, and here we can write this is 14 6 84, and 84 minus 15 is 69. So here we have 69 by 14. Now multiplying throughout by 14, we get 20x plus 23y plus 26z equal to 69. So viewers, this is the Cartesian equation of the plane P, and we can convert this equation into vector form, right? So what we will do, this equation is 20x plus 23y plus 26z minus 69 equal to 0. So we can write it as r dot 20 cap plus 23 j cap plus 26 k cap equal to 69. And here the normal vector is given by vector n, and this is 20 cap plus 23 j cap plus 26 k cap, right? So the normal vector is like this. Clear? Now for the plane P1 and P2, the normal vectors are like this. This is n1 vector, this is vector n, and the normal vector for this plane P2 is n2 vector, right? So this is the required equation of the plane passing through the intersection of these two planes, and this plane passes through the point 1, 1, 1. We can also verify that this point 1, 1, 1 lies on this plane. How? If we substitute the value of x equal to 1, y equal to 1 and z equal to 1 in this equation, we see that 20 times 1 plus 23 times 1 plus 26 times 1, and this is equal to 20 plus 23 plus 26, and this is 69, which is equal to the left hand side. So this shows that this point lies on this plane. Now let us take this problem. Here we have to find the equation of the plane passing through the intersection of the planes. The first plane is given by the equation 3x minus y plus 2z minus 4 is equal to 0, and the second plane is given by x plus y plus z minus 2 is equal to 0, right? So find the equation of the plane passing through the intersection of these two planes and the point 2, 2, 1, right? So we have two planes. So what is the equation of the plane P which passes through the intersection of these two planes is given by P1 plus lambda P2 equal to 0. Now P1 is 3x minus y plus 2z minus 4 plus lambda times x plus y plus z minus 2 is equal to 0. Say this is equation 1, right? Now we can also write this equation in the form 3 plus lambda times x plus minus 1 plus lambda times y plus 2 plus lambda times z, and then we have here minus 4 and minus 2 lambda equal to 0, right? Now this is the equation of the plane which passes through the intersection of these two planes. Now we are given the condition that this plane passes through this point. So plane P passes through 2 comma 1, and if we substitute the value of x as 2, y is equal to 2 and z is equal to 1 in this equation, we get 3 plus lambda times 2, then minus 1 plus lambda times 2, and then 2 plus lambda times 1, and here we have minus 4 minus 2 lambda equal to 0. Now this is 6, this is 2 lambda, this is minus 2 plus 2 lambda, this is 2 plus lambda, this is minus 4 minus 2 lambda equal to 0. Now 2 lambda and 2 lambda get cancelled, and here we have 6 minus 2 is 4, and these two terms get cancelled, so we have 2 lambda plus lambda is 3 lambda plus 2 is equal to 0, and lambda is minus 2 by 3, right? So this is the value of lambda. Now substituting this value of lambda in this equation, we get the equation of the plane P as 3x minus y plus 2z minus 4, and here we have minus 2 by 3, and then we have x plus y plus z minus 2 is equal to 0. Now if we take the LCM, we get 3 times 3x minus y plus 2z minus 4, and here we have minus 2 times x plus y plus z minus 2 is equal to 0. So this is 3 3s are 9x, we have 3y, then we have 6z minus 12, and then we have minus 2x minus 2x minus 2y minus 2z plus 4 equal to 0. Simplifying this expression, we get 9x minus 2x is 7x, minus 3y minus 2z is minus 2y, minus 3y and minus 2y is minus 5y, and 6z minus 2z is 4z, and minus 12 and plus 4 is minus 8 equal to 0. So this is the required equation of the plane which passes through the intersection of these two planes and passing through the point 2, 2, 1, right?